proposed plan to integrate a feed-through timer with a manual override switch for controlling a row of light poles is feasible, but several potential issues must be addressed to ensure safety and proper functionality. Firstly, power safety is paramount. Before commencing any electrical work, it is crucial to disconnect the power supply to both the timer and the lights. This measure prevents accidental electric shock during the installation process. Always use appropriate personal protective equipment, such as insulated gloves and safety glasses, and strictly adhere to all applicable electrical code requirements. Secondly, in timer mode, the timer must have exclusive control over the lights. Verify the load wire originating from the timer is accurately connected to the common terminal on the three-way switch. Furthermore, it is vital to confirm that the traveler wire extending from the timer is connected to the correct traveler terminal on the three-way switch. This configuration ensures the timer can activate and deactivate the lights according to its programmed schedule when the three-way switch is in the designated timer mode position. Thirdly, concerning manual mode, the single pole switch located upstairs should have complete control over the lights. Verify that the switch loop wires are correctly connected to both the three-way switch and the single pole switch. Make absolutely certain that the line wire emanating from the timer is properly spliced onto the switch loop. This connection is essential for supplying power to the single pole switch, enabling it to turn the lights on or off when the three-way switch is in the manual mode position. Fourthly, calculate the total wattage of all the lights connected to the timer. It is vital to ensure that the three-way switch and the single-pole switch possess an ampacity rating that is sufficient to handle the entire electrical load. It is highly recommended to consider employing a heavy-duty three-way switch and switch loop wire. This will ensure they can safely and reliably manage the current demanded by the lighting system. Fifthly, grounding is a critical safety aspect that must not be overlooked. Verify that the handy box and all other electrical components are properly grounded. Utilize ground wires and grounding screws wherever necessary to establish a secure and reliable ground connection. This measure minimizes the risk of electrical shock and ensures the overall safety of the installation. Once the wiring is fully complete, conduct thorough testing of the system in both manual and timer modes to confirm proper operation. If any issues arise during testing, carefully examine all wiring connections to identify any potential errors. If the troubleshooting process proves challenging or you are unable to resolve the issues, consult with a qualified electrician for further assistance. It is always best to seek professional help when dealing with electrical systems to ensure safety and compliance with electrical codes. Additionally, consider the following points to enhance the reliability and longevity of the lighting control system. Selecting the appropriate type of wire for the switch loop is important. Use a wire gauge that is suitable for the current load and meets the requirements of the electrical code. Typically 14 AWG or 12 AWG wire is used for lighting circuits, but always refer to the electrical code for specific requirements in the location. Ensure all wire connections are secure and properly insulated. Use wire connectors or solder and electrical tape to prevent loose connections and shorts. Loose connections can cause overheating and potentially lead to a fire hazard. When installing the three-way switch and the single-pole switch, make sure they are securely mounted in the handy box or wall box. This prevents them from becoming loose or damaged over time. Label all wires and connections clearly to avoid confusion during future maintenance or troubleshooting. Use wire labels or a permanent marker to identify each wire. Consider using a surge protector to protect the timer and the lights from voltage spikes or surges. Surge protectors can help prevent damage to electronic components and extend their lifespan. Regularly inspect the wiring and components for any signs of wear or damage. Replace any damaged components promptly to prevent safety hazards. Keep the handy box and wall box clean and free from dust and debris. Dust and debris can accumulate over time and potentially cause overheating or malfunction. Consider using a weatherproof handy box and cover if the installation is located outdoors or in a damp environment. This will help protect the electrical components from moisture and corrosion. If the lighting system is controlled by a smart timer or a home automation system, ensure compatibility between all components. Refer to the manufacturer's instructions for proper setup and configuration. When working with electrical systems, always prioritize safety and follow all applicable electrical codes and regulations. If there is any doubt about your ability to safely perform the work, consult with a qualified electrician. By carefully considering these potential issues and implementing the recommended solutions, the customer can have a safe and reliable lighting control system that meets their specific needs. The combination of a feed-through timer and a manual override switch offers flexibility and convenience, allowing for both automated and manual control of the light poles. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. Never work on live circuits, always disconnect the power before starting any work, and use appropriate safety gear. If you are not comfortable working with electricity, consult a qualified electrician. They have the training and experience to safely and correctly install and maintain electrical systems. In addition to the points mentioned above, there are a few other considerations to keep in mind. Consider the placement of the three-way switch and the single-pole switch. They should be located in convenient and accessible locations where they can be easily operated. Ensure the wiring is properly supported and protected. Use cable staples or other appropriate fasteners to secure the wiring to the building structure. Avoid running wires through areas where they could be damaged or exposed to moisture. When making wire connections, use the correct size and type of wire connectors. Ensure the connectors are properly tightened to prevent loose connections. If you are using solder and electrical tape to make wire connections, make sure the solder joints are smooth and free of sharp edges. Wrap the solder joints with multiple layers of electrical tape to provide adequate insulation. When installing the timer, follow the manufacturer's instructions carefully. Ensure the timer is properly grounded and connected to the correct voltage supply. If the timer has a backup battery, make sure the battery is properly installed and charged. Regularly test the backup battery to ensure it is functioning correctly. If the lighting system is controlled by a photocell, make sure the photocell is properly positioned to detect ambient light levels. The photocell should be located in an area where it is not obstructed by trees, buildings, or other objects. If the lighting system is controlled by a motion sensor, make sure the motion sensor is properly positioned to detect movement. The motion sensor should be located in an area where it has a clear view of the area it is intended to monitor. Regularly clean the photocell and motion sensor to ensure they are functioning correctly. Dust, dirt, and debris can accumulate on the sensors and reduce their effectiveness. If the lighting system is used for security purposes, consider installing additional security features such as security cameras or alarms. Security cameras can provide video surveillance of the area, while alarms can alert you to any unauthorized activity. Regularly inspect the security features to ensure they are functioning correctly. Test the alarms periodically to make sure they are working properly. If the lighting system is used for decorative purposes, consider using different types of lights to create different effects. For example, you can use spotlights to highlight specific features, or you can use colored lights to create a festive atmosphere. Experiment with different lighting arrangements to find the ones that you like best. Remember to always prioritize safety when working with electrical systems. Follow all applicable electrical codes and regulations, and if you are not comfortable working with electricity, consult a qualified electrician. To further elaborate on the selection of appropriate wiring for the switch loop, it is essential to consider the National Electrical Code or NEC. The NEC provides specific guidelines for wire gauge based on ampacity. Ampacity refers to the current carrying capacity of a wire. The NEC mandates that the wire used in a circuit must have an ampacity rating equal to or greater than the non-continuous load plus 125% of the continuous load. Continuous load is defined as a load that operates for 3 hours or more at a time. For lighting circuits, the load is typically considered continuous. Therefore, the wire must be sized to handle 125% of the lighting load. For example, If the total wattage of the lights connected to the circuit is 1200 watts on a 120 volt circuit, the current draw would be 10 amps. The calculation is 1200 watts divided by 120 volts equals 10 amps. To determine the minimum wire size required, you must multiply the continuous load by 125%. In this case, 10 amps multiplied by 1.25 equals 12.5 amps. According to NEC Table 310.15b16, a 14 AWG copper wire has an ampacity of 15 amps, and a 12 AWG copper wire has an ampacity of 20 amps. Therefore, in this example, a 14 AWG copper wire would be sufficient. However, it is always recommended to use a 12 AWG copper wire for lighting circuits. This provides a safety margin and allows for future expansion of the lighting load. It is also important to consider the voltage drop in the circuit. Voltage drop refers to the decrease in voltage that occurs as electricity travels through a wire. Excessive voltage drop can cause lights to dim and appliances to malfunction. The NEC recommends that the voltage drop in a branch circuit should not exceed 3%. To calculate the voltage drop in a circuit, you need to know the length of the wire, the current draw, and the wire size. There are online voltage drop calculators that can help you with this calculation. If the voltage drop is excessive, you may need to use a larger wire size to reduce the voltage drop. The type of wire used for the switch loop is also important. The most common types of wire used for residential wiring are non-metallic sheath cable, also known as Romex, and individual conductors and conduit. Non-metallic sheath cable is typically used for new construction, while individual conductors and conduit are typically used for remodeling projects. The type of wire you use will depend on the specific requirements of the electrical code in your location. It is also important to consider the environment in which the wire will be installed. If the wire will be exposed to moisture, chemicals, or extreme temperatures, you will need to use a special type of wire that is designed for those conditions. For example, if the wire will be installed underground, you will need to use underground feeder or UF cable. UF cable is designed to be buried directly in the ground without the need for conduit. It is also resistant to moisture, chemicals, and abrasion. When making wire connections, it is important to use the correct type of wire connectors. There are many different types of wire connectors available, and each type is designed for a specific application. Some common types of wire connectors include wire nuts, crimp connectors, and push-in connectors. Wire nuts are typically used for connecting two or more wires of the same size. Crimp connectors are typically used for connecting wires of different sizes. Push-in connectors are typically used for connecting solid wires. It is important to use the correct size wire connector for the wire size being used. Using the wrong size wire connector can result in a loose connection, which can cause overheating and potentially lead to a fire hazard. When tightening wire connectors, it is important to use the correct torque. Torque refers to the amount of force applied when tightening a screw or bolt. If the wire connector is not tightened enough, it can come loose over time. If the wire connector is over-tightened, it can damage the wire or the connector. The correct torque for a wire connector is typically specified on the connector packaging. It is important to use a torque wrench to ensure that the wire connectors are tightened to the correct torque. When installing electrical tape, it is important to use the correct type of electrical tape. There are many different types of electrical tape available, and each type is designed for a specific application. Some common types of electrical tape include vinyl electrical tape, rubber electrical tape, and silicone electrical tape. Vinyl electrical tape is the most common type of electrical tape and is typically used for general-purpose applications. Rubber electrical tape is more flexible than vinyl electrical tape and is typically used for applications where the tape needs to conform to irregular shapes. Silicone electrical tape is heat-resistant and is typically used for applications where the tape will be exposed to high temperatures. It is important to use the correct type of electrical tape for the application. Using the wrong type of electrical tape can result in the tape failing over time. When wrapping electrical tape, it is important to overlap the tape by at least 50%. This will ensure that the tape provides a good seal and prevents moisture from entering the connection. It is also important to stretch the tape slightly as you wrap it. This will help the tape to conform to the shape of the connection and provide a tighter seal. When installing the timer, it is important to follow the manufacturer's instructions carefully. The timer should be installed in a location where it is protected from moisture and extreme temperatures. The timer should also be installed in a location where it is easily accessible for maintenance and adjustments. Before connecting the timer to the electrical system, make sure that the power is turned off at the circuit breaker. This will prevent electrical shock. Connect the timer to the electrical system according to the manufacturer's instructions. Make sure that all wire connections are secure and properly insulated. Once the timer is connected to the electrical system, turn on the power at the circuit breaker and test the timer to make sure that it is working properly. If the timer is not working properly, consult the manufacturer's instructions for troubleshooting tips. When installing the photocell, it is important to follow the manufacturer's instructions carefully. The photocell should be installed in a location where it is exposed to direct sunlight. The photocell should also be installed in a location where it is not obstructed by trees, buildings, or other objects. Before connecting the photocell to the electrical system, make sure that the power is turned off at the circuit breaker. This will prevent electrical shock. Connect the photocell to the electrical system according to the manufacturer's instructions. Make sure that all wire connections are secure and properly insulated. Once the photocell is connected to the electrical system, turn on the power at the circuit breaker and test the photocell to make sure that it is working properly. If the photocell is not working properly, consult the manufacturer's instructions for troubleshooting tips. When installing the motion sensor, it is important to follow the manufacturer's instructions carefully. The motion sensor should be installed in a location where it has a clear view of the area that it is intended to monitor. The motion sensor should also be installed in a location where it is not obstructed by trees, buildings, or other objects. Before connecting the motion sensor to the electrical system, make sure that the power is turned off at the circuit breaker. This will prevent electrical shock. Connect the motion sensor to the electrical system according to the manufacturer's instructions. Make sure that all wire connections are secure and properly insulated. Once the motion sensor is connected to the electrical system, turn on the power at the circuit breaker and test the motion sensor to make sure that it is working properly. If the motion sensor is not working properly, consult the manufacturer's instructions for troubleshooting tips.